welcome back to the second part of Pandas tutorial. First part we have covered a lot, and in this part we will try to enhance our knowledge. So let's get started. Let's take a look and see how we could get the unique values in the columns. Here, as you could see, that I'm just getting a list of all the values from the column name is name here. Here you could see that in the column sex, we are getting two unique values, male and female. If you look into age here are the unique values in the column age. If you would want to know how many unique values are, you could say length, and here it will say in the age column there are 891 rows, so that many values are there. But if you want to know the unique values, here you could say, you can call the unique method on the data frame, and you could select the particular column you are interested into. Next, if you would want to have this df age, so for example here we are storing this value, so you could say that df age is really look like that way, which is this value, as you could see here, because we are getting this value age. Or if you are looking into this, here you could see that in the data frame name, column name is age, value count. So depending on unique values and their count, you could call this way. So value count will also work for you. And here if you look into the df age, which is exactly the 89. So there are various ways you could find the unique values in a column. If you look into the name, if you say, what if I would like to get the name column here, you could actually use this, and you would see that there is almost every name is unique here. So that's how you could see that the uniqueness in the name may not be that much applicable depending on our problem. In this scenario where you had to male and female, you could actually filter on male, and you can actually filter on female unique values, and that's how you would be able to get it. So this is way, and this option is to get the unique values and how many they are. Out of 89 unique values, it tells the distribution of that, and later we also learned that how to bin these values. So you could actually create a bucketization in your given value min and max and the number of bucket, and then that bucketization will help you to put various values in depending on those buckets. The next step is to change values in the existing column. So let's see what happens here. So what we are trying to do here is that here in the age column, we are trying to get how many null values are there. This way we are rendering for every value in the age column, whether it is null or not. If it is null, it's going to be true, otherwise it's going to be false here. So if you would want to process your age column and you would want to say that I would want all the NA must be filled with 0. So here df age, we are saving it. If you would do this way, everything will happen in memory. But here, rather than doing in memory, we are actually storing the results back into the df age column. And here we are expecting that all the null values are filled with 0. So this result should be 0, which is this. So now all the 177 values, they are filled with 0. So we are changing the values. That's one option here. Or if you look into another way to change this is another way to change this. The only issue here is that this function is required np.n, so it needs a numpy package. So we are not going to use here because I do not want to bring the numpy in the mix right now. I just want to have just only pandas. As you could see here, that if you would want to do some update and you want to create a new column, so here just for an example, we are multiplying every value in the age column by 3 and storing age times 3, as you see here. And if we do sample here, very quickly you would see that we have seen a one more age column where the value is. So let's try to use the 10 samples here. And as you could see here, depending on what the value was, there is a like 3. If we look into the df sample, or if you would want to see the df age, and age times 3, that can also be seen here. So how we could do this? We could say df of age and age times 3, as you could see here, and this way we could see the age and age times 3. So this is how you could update the numeric value directly, or you could, or if you would want directly in the same column, rather than using age, you could actually use the same column, and then the particular column within that data frame will be updated to the desired value. There are a couple of other ways can be done using apply and apply to or lambda to, but those will be coming in the advanced pandas area. Our next topic is the changing the string column values to uppercase or the lowercase. So here you could see that in the name, we are converting every name value to the uppercase. However, if you look into the df, the values are not upper because it does not change in place. If you want to change it, you have to store those values back into the data frame column, and that's the reason once we do this way, then those values will be changed. Same thing is a lower. So here you just tell that which particular column you are interested to change upper or lower, and depending on your selected column you could choose the .str method and .lower or upper, and those values will be changed. So once I will do that way, the df, and now if I try to again do this, and you will see that all the values are upper now, and if I want to lower them, I will run this guy and I will come back again, and now everything is lower. And there is one more option available, is that if you can try is and here, and that is called capitalize. Let's see, CA capitalize, and if you try to use that here, and there you go, you could capitalize back. So you have uppercase, lowercase, or capitalize the string value. And same thing you could do to mail here. If you would want to that thing for the mail, you could actually use here, and you could say I would like to have the, okay, and if you look into here, df, and you could see that upper things could be. So this is how you could change the string values within the data frame column, uppercase, lowercase, or capitalize it. Next, we are going to learn how to remove column values from the data frame. So as you could see, we still have our data frame. So this is our data frame, and then most of the values we did play with them, and after our experimentation we end up adding these 3 columns here. So if we would want to remove the column, we could actually do this. So if you see here that we have age above 50 and age above 50 in male, so these are the 2 columns we have, and if you want to remove them, and if you look into here, that's command, and then if you df, those columns are removed. So those are the in place equals true. If we would have not used in place equals to, we would have made them false, then the data frame update will not affect to the existing data frame where this drop method was called. So you have to remember that part. So we are deleting columns by name and using in place here equals true. Next, if we want to delete the row by index, it means we need to find the actual row and then delete it. So remember, we have already looked into earlier that how to get an individual row, and if you know that what's this index is. So first we are going to read this database local source and using the index name. So as you could see here, our data frame has these index, so it's a new data frame we have just created using this data set. Next, we are trying with the data frame to use the drop, and rather than giving the name, as you could see here that previously we are using these column names here, we are giving the drop and we are giving the value here. So what changes at this point is that as soon as you are going to see this data frame, you see that this is the index value, and then here is that. So if you take this index value, you say in place equals true, and you run this, and as you could see here, that record number 3 is removed. So for the indexed value, the calling this drop method is going to look into the index column and search this exact value, and if exact value is found, then that particular row will be removed. So here you could see that in this scenario we are using this, which is the one row, and we are using another row which is also here. And if we try to run this, because that row was already been deleted, we have already made that call, and as you could see here, both of those rows will be gone. In this scenario, what we could do to make it run, we reload this again, we run this, we drop one record. As you could see, that record is removed. Now we remove these two, and then that's the way. So our experiment is correct. Next, again in the data manipulation section of pandas, let's try to update the cell value directly in the data frame. So we are taking the data frame, and as you could see here, that we are getting the record number 100 from the index, and here we are taking that record and converting that to a data frame. So that's the only big difference, is that the result is back to the data frame from the parent data frame, and it also using the parent data frame header. As you could see here, in the same value, we are only getting at this point, as you could see here, that we are looking into the survived, but because of in this example our survived is survived trip, so because we have earlier changed this value, so now it became survived trip. So you could see here, that's the index here. We will change here, as you could see here, the survived value here is the 0, survived trip is the 0. So if you try to do the iLock integer location, and you are trying to set the value, as you could see here, that value is updated or not, that we could check here, and as you could see here, that value was 0 and value is still 0 here, because if you see here, that request is to use this way: location, row indexer, and call indexer, row and column, which row and which column you would want to change this. So as you could see here, the survived trip is still the 0 value. Now we have df with index. As you could see here, in this df with index, we are looking into, as you could see, all 0 to 10. So first 10 records we are looking into here. As you could see, I'm looking into the very first record. As here, because this is a new record, so I think I should be calling survived here based on this. It's a df with index, so that should be all survived here. So this is a new data frame, we just created df with index. Okay, so here survived. So if you look into here, the survived value is 0. Now we are using iLock as suggested, and in this first row iLock 0, 1 and set 1, and as you could see here, in this the value 0 is updated to 1, and even when there was this warning, the update does happen. So that's one way you could see that in value in place could be changed directly. And there is another option here. You see that we are getting a particular record. So you see location df with index get ticket equals this value. So we are finding a particular ticket which look like STON. That should be this record. So it's record 885 ID here, and survived. So you see here that for this, the survived value. So df with index location, and now we are trying to say survived here. Okay, series. Okay, reading again. So now we are reading the data frame again here, and df with index. Now we have that value. So we are saying df with index get this value. As you could see here, we are able to get this record. Now we want to know what is the value of survived in the same record. So here you could see the survived value is 1. That is the survived here. Now with location survived, it's set to 10 here. Okay, or survived is equal to 0 is better value. We have run this 0 value. Now if you look into here, this survived became 0. And here we did not get any error. So this way was a much better method we have used to do the in place update by finding a particular row index based on a certain condition. So that's what we have done to make sure that everything is working and in place update to the data frame can be completed successfully without a warning, and that's how we could get it done. In this 5th section of Pandas tips and tricks, we are going to look into various data handling methods such as sorting, finding smallest, largest values, as well as binning the numerical columns. So let's get started. First, importing pandas and loading the local data set, which is Titanic, and here is our data set. So far you have already got this thing covered. Next, let's try to sort here. So what we are doing first is that we are trying to read the data frame based on column name, and if we want to sort on index, because now we already know that name is our sort column and we would want to sort these values. Here you could see that values are not sorted, and here you can say that df with index sort index and x is 0. So you would want to sort this column, and as you could see here that passenger ID is arranged in a way based on the name value is sorted. If you want to do the ascending equals false, and as you could see here that here the values were in ascending order, so A to Z, but if you say ascending equals false, then values are opposite. They are in descending order. If you would want to sort the same sort values on passenger ID, so you see here this is a passenger ID and we are sorting here, and as you could see here that passenger ID is 1 to 8. So it was the original data, because if you remember this is the way. So now the data frame is gonna be look like same way. So it's a data frame, and if you see here that we are sorting the values, so the results are immediate available. The original DF index is still the same. It's not being updated here. If you want to sort on ticket, as you could see here, so ticket values are sorted. If you would want to sort on PC class, this is the PC class is used here, and if you want to say PC class ascending equals false, and then you could see here. So sorting is based on index. So that's a really very quick way to sort. You already have an index database in order to make the sorting work. Now we are trying to sort on 2 columns and their order. So here we already have the indexed database and we are trying to do the sort. So sort values, here you see that I'm passing an array of 2 columns and their order ascending or descending. As you could see here that 2 columns and their orders was added. Next you could use the 3 columns and then you can pass the order of them, ascending or descending. So depending on each column name, you need to add your choice, and that's how you would be able to sort it. And as we look into here, while we were trying to do the processing, our original data frame is still the intact. It was not changed, so there was no in place update. If you want to do in place update, the best option is to store this result back into the same data frame, and that could be done. Next step for us to get the larger values in the given data frame based on given column. So here you could see that age is the numeric column, and we are saying that give us the top 5 largest values available and using n largest method on the given data frame. So what is happening here, you see that we already know that highest age is 80, so all the top values are available for us. If you say give me the all 1000, and in this scenario, because your record is about 891 record and we also have about 177 empty age value, so you could see that all the non-empty values are listed here. So if you want to get the largest value based on given column name, you could just pass the top n values you want based on your n largest method, and the data frame result will be available for you. If you want the smaller value, you just need to use the n smallest, and here you could see the smallest age values, those are available for us. Same thing you could get depending on all the available values. So we have about 714, so you get 500 based on the number of values you want for this given age column. In the next section, we are going to pivot it. So what is pivoting? So pivoting is basically when you want to convert a column to row name and index. And once I will give the example, that will be easier for you to understand. So first, we are reading this data set and we want this data set to be used for pivot. So we have read this. Very simple, no index, nothing. Now what we want to do is that we want to take this data frame and we want to pivot it. And our index is the sex and the column we want to use name. It means that every value available in this column, you have to understand every value available in this column will become the column here. And let's see what happens. Once you will see the result, you will get an idea. So you see here that at this point we have 8910 column. Okay, so here you could see here that index is sex. So we have female and male. So sex value became, all these sex values became the index values. So we have two index, female and male. And for every value, for every record which was the name is being added. Now what's going to happen is that, so we have 12 columns. Column sex is used for index, name column is used for all those column name. So for every column available, you are going to get, so this is a first value is for passenger ID. This is next for embark. So what's going to happen is that you had 12 columns. Two columns are used, one for index, second for column name. So 891 times 10. So for every column value, that many columns are created. So that you got an idea. So as you could see here that there are 2 rows and 8,910 columns, and that is based on total number of values we had and the number of columns. So 891 times 10, and 2 columns are used here. So that was just to give you a quick idea that how you can take every value from your given column and you can very quickly convert it. What if we do a very quick change here? We call it change. Okay, and here what we are trying to do is that we are pivoting this to name and sex. Now let's see what happens. So index became name and sex is the column here. So we run this, and now if you look into here, you will be seeing. So you see here that now what has happened for every index name. So for every value in the name became index. So we already know there are 891 names. So that is already there. And now you have columns. So remember, for every column value, there is 2 values, male and female. And then you have 10 columns. So 10 twos are 20. So you have 20 columns, and that's how you are going to create a new data frame which is pivoted based on column sex and index, which is the name values. So that's how you will be able to understand pivoting works. So here from the pivoted column, we are getting those values. So here you see that we are getting these 3 columns. So these are the 3 columns, and now we are trying to pivot. If you have so many columns, so first you filter out exact columns you are interested into. Here you see that we have PC, class, sex, and name, these 3 columns, and now we are trying to pivot the df pivot, and based on these 3 columns. And as you see here we got some better understanding of. So based on the classes, we know this person was in class 3 and this person was male. This person female in class 3. If you would want to know this person female in class 2, this person is female in class 3. So that's much better if you have 3 columns, because it gives you much better understanding about how the rows transfer from rows to column is going to bring the changes into this new data frame. So that's, you have to understand. Our next step is to capitalize all the value in the specific column. So here you see that we have a data frame and the sex column is something like that. Here you could capitalize it and all those values will become male. So I think we have already looked into that example. There is one try which we could try here, that we could take the full data frame and try to capitalize it. So now you see that we try to capitalize it, and now you see that it will not work because this data frame has no attribute str. Means that in order to capitalization has to work, you have to use the object column, means string column. If you will try to use column like age, and if you try to run, you will get an error because age cannot be capitalized, it's a numeric. So in order to make this work, you have to use a particular column, something like that. So if you say capitalize, you can use this ticket column, and if you try to capitalize, that will going to work for you. Okay, so here, and let's try to use the df ticket equals to capitalize, and now if you try to use the df data frame, and you are going to see this capitalized. So very first letter in all these string will be capitalized. The next item in our list is creating binning. So if you would want to create the bin, it's just a one-line command, honestly. So very easy to do it. Here you could see that we are getting these 5 top rows from our data frame. Here you could see that our age value, which is a numeric, here you see that we have 714 values, mean 29, the minimum is a 0.42 and the maximum is 80. To create the bin, you need to use the cut method on the pandas, and you pass the column, which column you would want to create the bin. So data frame age is our column, number of bins we want depending on min and max. The data will automatically shift number of bins you want and include lowest equals true. So you can say, yeah, you know, the go with the lowest value available, and you can use that as the minimum, and the bin is added. And if you look into here, we are sorting database based on bins, and here you could see that our values are sorted based on bin here. And if you would want to this, okay, and if you want to say that way, you could see that the higher values. If we take this well and we use this, and that's why you could see that we have the values. So we have values between 0.42 to 80, and we have 10 bins, and based on 10 bins we have got this value. If you would say I just want only 2 bins, it means the around 50, like a 0.42, we try to use 2 bins. Now you see here that there is a 0.339 to 40 and other, and if you look into the upper side, 40.21 to 80, so it's a 2 bin. If you would want to use 20 bins, you change this. Now if you see here, values are shifted accordingly. That's how. So just using one method, cut on the data frame, and then by passing your numeric column and passing the number of bins you want, you could create a new column, and that column will have all of your values based on your binning. And if you would want to figure it out how many unique values you have depending on each bin, you already know how you could perform that. This section of pandas tips and tricks, we are going to look the splitting and merging the data frames. First thing first, importing the pandas, and then as you could see that we are going to load the local Titanic data set into this data frame df, and as you could see here, we are creating a new data frame where all the male values are stored here. So 577 rows with all 12 columns are available in data frame male. And how we split it, here is the, so we have taken the data frame sex equals male. So this is the condition we have set, and we apply that condition to this data frame. Once this condition is applied, database filtered, and the result of filtered database is stored into df mail, and that's how your mail data frame is created. Similarly, we have used sex equals female and performed the exact same operation, and now we have data frame female available, and here you could see 314 rows. So 577 male and 314 female records we have in this given data frame. So we are splitting based on column values. At this point, the headers are same, so that is the horizontal split. We had 891 rows. We split them into 577 and 314 rows of two different data frames. If you would want to do the vertical split, it means you want to take few columns in this and few column in that. So if you see here, if you want to create a data frame where the columns are, do not use the name column here, for example. So first data frame, we have 4 columns: name, sex, age, ticket, and we have another column. Just right now there are 7 columns. Okay, as you see here, 1, 2, 3, 4, 5, 6, 7. So these two data frames are very independent data frame. There is no connection whatsoever between this data frame and this data frame. So if you are splitting a data frame, you need to make sure that there is some dependency between them. So now you could see for the Mr. Owen Harris, their sex is male, age 22, and this is a ticket number. And for the same person, there is other more data available. So having a common column among multiple data frames help you to join the data frame together, because if you want to merge this data frame together, at least we do have a column which is common between these two data frames or data sets. But currently they are data frame here. If we save these data frames to the disk, then they will become data sets. So next we need to learn that how we could combine these data frames. So we have seen that we learn how to do horizontal split and how to do the vertical split. Now we will use these data frames available we have to combine them. So very first operation is concat. So concatenation happens when you want to combine the rows with header. But at this point, the concatenation does work on both ways. You can do row wise and you can do column wise. So here is the method which is concat, which is applicable to the pandas, and you need to pass the object. So here you could see that we are passing the two objects, so male and female, and we want to concatenate it. So here is a mixed data frame combining male and female. And if you see here, we got 891 row. Very simple. We passed the male and female data frame, and then result of these operations was stored in third new data frame, and that became our data frame here. If you see here, reset index and drop equals true. So you see here that we have this, and if you want to run this thing, as you could see here, that in this scenario, if there was index in those data frames, it will drop reset index. It will reset the index. As you could see here, male and female, the numbers are different here. Now, if we want to do the ignore index equals true, and if we try to concatenate male and female, as you see here, 891 rows and 12 columns. Okay, if you combine here, as you could see here, next we are doing the concatenation, passing the male and female data frame, and we are also saying that the result should be sorted on ticket column. So here you could see these are the ticket. Let's try to sort it. At this point, the concatenation will happen, and as you could see here that these values are index are updated because the results are sorted on ticket columns, and that's where your ticket column is right now. So this, I have added this method there. So if you would want to learn more about some of these values, you can go ahead, you can learn them, and you can understand. And as you could see here, there is a join option. So how different ways you want to do inner join, you want to do outer join, and depending on your first and second data frame, you could perform these various intersection. My plan is to talk about these inner and outer join in the advanced version of Pandas data frame tutorial. So I will pass that here. Now we are trying to use same concat option, but in this time we are going to merge the columns. As you could see here that axis 0 is default, means when you are going to concat, the expectation is that you are trying to do the rows concatenation first, and that's why it's default. However, if you would want to concatenate the columns based on a common column name, then you need to pass this axis equals 1. So here we have concat left and concat right, and we are combining concat left and concat right, and here is our result. So as you could see here that this is not in place. So if you want to save this result, you could go ahead and you can store this data into the third data frame where it's going to happen. If you would want to store one data frame into another one, then we have other options available to merge those data frames. So we have looked concat right now. Our next option is to use the merge option. As you could see here that merge option is available on pandas, and here you are passing the left and right data frame and how you would want to merge it. So again, you have inner and outer, so you are intersection and union. And union, basically when you have a comma, so there are several things can be done within those merge option, but here just for a quick walkthrough, I will be just showing you very simple example to get you started. We have data frame, creating a one data frame which is based on name, sex, age, and ticket, and we are creating another data frame which is based on remaining columns, but the name column is common between these two. And here we are using just pd merge. Very simple. As you see here, pandas.merge, passing left and right, and results are merged into 891. So very simple to concat here, passing merge. We haven't really deep dive into the differences could be. Here as you could see here that we are merging at this point, but our data frame are indexed here. This is the df indexed. We are reading local data set with the index column is passenger ID. So we have passenger ID, which is our index column. And now we are creating data frame which are indexed here. So you see here the passenger ID is index column here. Data frame 1, data frame 2. So passenger ID is the index, and if we are trying to merge here, as you could see here that left index is true and right index is true. It means apply the indexes from both of the data. And as if you could see here, your merge database has the passenger ID and it's merged everything. If we try to do the merge operation where the male and female, which are non-indexed data frame, if we try to do here df merge, and as you could see here that because of merge there is no left or right indexes here, so merge could not be performed here correctly. And as you could see here, this data frame does not have any indexed value, so the result is 0. So in order to make this whole merging should work, you need to have the index column applicable to you. So this is the non-index merge here, and as you could see, it's all 891. But when you are trying to merge these two columns, it does, as you could see here, we are merging. So we say, hey, use the left and right index for this data frame. So you have to make sure that you understood this part clearly. After merge, we are looking into the join method. So we are combining two data frame in join. And here you could see that join method is applicable to the data frame. It means we will use one data frame and apply the join method and pass the other data frame for this to work. So how is a left suffix and sorting is also built into. So df join left, and we are taking the df part 1. So df part 1, which is our first this data frame, and we are saying that df joined left and df part 1, and then we are adding the df part 2, and this is how your whole joined is available. So you could see left is there, common name is there, and then the rest other 3 columns available from df part 2. If you see here df join right, so we are using the df part 1 join and how is right. And if you look into right here, as you could see at this point, that in this example, how is equal to right here, and if we try to use the same example here, and we can say left and use the left. And the next option is to use the append method, where we are trying to combine. So append is applicable to data frame. As you could see here, that we are data frame dot append. Okay, and is row axis where the headers are same between the two data frames. So two data, df male, df female, and we are adding all the female records into the df male. So it's appended record, as you could see, 891. So all the males and all the females are added. So here we are taking this data set, we are making this all the male values to the local, and then in the male local we are appending the female. And as you could see here, df male local is a 577. It means that when we try to append this value, the result was shown here, but the local was not updated. It means it was not the in place update. So if you want to store the result of append method, you have to save them in your target data frame. And that's the thing you really have to take from this example. So these are the merge data frame options, are quite similar in one way or another. Some are applied with pandas, some are applied with data frame itself. So you just need to know which one applies where. The next method we have is pandas update, and update function does the in place data update in the data frame whenever it is called. So here I just wanted to show you that it was not in place. So if you want to append, then you need to store result in the target data frame. If you have a requirement where you want to update the data frame which is calling this append method, then rather than append, use the update, and values will be updated here. So you see here we have df male, we have female data set. Now we are creating a male local. So we have male local, and using male local we are updating all the female values. And if you look into here male, if you see here, df male is showing, female is not added here. Very first thing with update you have to understand is that it does not, first it does the in place data update, second it does not add the new rows. Instead the update happen within the data frame which is given data frame, and if there is a matching row available, then if there is a matching row, then the selected data will be updated. And if there is no matching data in the second data frame, the first data frame will not change. So first we have male data frame, then we have female data frame. And here you could see that we are storing the male data frame to the local data frame, and then adding then calling this update method to male data frame. And as you could see here, if it was the previous method which we just learned about using a append, then local would have appended with new records. But if you see here, there is no change in the male local. It means none of the values from data frame female is matches with male, and therefore that's why there is no update. So if we want to get this update method working, we need to select a particular row from this given data frame and change some of the value and then update it. So as you could see here, I'm looking into the 101st record from male, which is the passenger ID is 151. If you see here, I'm looking into the 10th record, which is look like that way. And as you see here, I'm taking the 10th record and converting that record to a data frame first. Now we will take this record and select a row. So now it just tell that we have a row selected here. Now in the selected row, we are looking into the passenger ID 22, which is survived. So you could see here the value is 1. And if survived value is 1, we will save that value to 5. And if you look into row value selected, this value is updated to 5. And if you would want to update this differently, I have already talked about in the previous section where how you could update it using ilog and passing the row and column index. So here the row value is 5. Now we are using the male data frame, and using update we are passing the selected row which just updated the file. Here you could see we have updated it because it's really telling us that yeah, update happened, but it's not a good way to do it. We should use the row and column index. And now we will look into the same record, 10th. And you see here the 10th record, survived values updated. So this is how you could understand how the update method works on the given data frame. So that's all I had in this tutorial for you to learn about Panda. So you learn 50 different ways to play with your Pandas library to process your given data set. One bonus tip, that there is something called pandas.read clipboard. So if you, for example, copy this thing, I have just copied in my memory, and if I try to get what it is, this is, you could see. So anything you try to say, copy, if I copy this whole data, I just copied it, I say render it, and this is how you could see that all that. So anything which can be copied here, as you could see here, can be converted into the data frame. If I try to copy all of this data, which you have seen here, and I say copied, and sorry, so if you see here, I'm gonna copy this data, copy and read clipboard. As you could see here, it's trying to convert to the data frame, but there is just some issue here, so it cannot convert to the data frame. However, if I try to read a string data such as this, and using that, if you see here, the pandas is trying to convert. So read clipboard, what it does, it takes the data from the clipboard and convert into the data frame. So other way look into, if you take the data such as this. So if you take this data, as you could see here, I have copied that record. Now I say read clipboard DFC, and if you see here DFC, all the data became something like that. So there are a couple of ways you could play with your read clipboard method to get your records in this way. One option could be that I could use this method. So let's try this whole. So I'm taking this whole row, copying in memory, running this clipboard method, and as you could see here, everything is try to shift in a way that it looks like a data frame. It's not a good, because you could see the name is really broken into, so this column thing is not really working very well, but I think you get an idea that how this pd.read clipboard method could help you if you have a need to split your copied data in the clipboard and convert into a data frame. There is still a lot to learn about pandas, and I will be creating another advanced version of tutorial to cover which could not be covered in this tutorial. So far, what you have learned, I'm sure you can apply at majority of the places where Panda library can be applied. So I'm glad I had opportunity to share some of the knowledge with you, and I will see you in my next tutorial. That's all, my friends. If you have enjoyed our content, please like it, share it, subscribe it. And finally, please remember, be good and do good. Thank you.